Now in this question we are asked to determine Km, and we have been given the rate of the reaction, which is 44% of Vmax, and a substrate concentration of 97.6 micromolar. So how can we do this question? First of all, let's write down the Michaelis-Menten equation. V equals Vmax times the substrate concentration divided by Km plus the substrate concentration. And it is this one here that we want to figure out. So what can we do? First of all, we divide both sides by Vmax, because we actually know that this is a certain percentage. So we bring that to that side. We know that V over Vmax equals 44%, or we can also write this as 0.44. So that's this percentage here. And so we have 0.44 equals S over Km plus S. So what we do is we bring this part to this side. We get 0.44 times Km plus S equals S. Now the next step is to multiply this 0.44 into the bracket, and we get 0.44 times Km plus 0.44 times S equals S. And that's fairly easy to solve. What we need to do is bring everything with S to one side and everything with Km stays on the other side. So we've got 0.44 Km equals S minus 0.44 times S. And in this case, I can factor S out. So that would be S times 1 minus 0.44. which of course is 0.56. So we have 0.44 Km equals 0.56 times S. All I need to do is divide both sides of the equation by 0.44, and I've got Km equals 0.56 divided by 0.4, and we've been even given a concentration of S that was 97.6 micromolar. So we can multiply that here, 97.6 micromolar. And if we put that into a calculator, we get a value for Km of 124.2 micromolar. So at 124.2 micromolar, so at 124.2 micromolar, we will get exactly half of Vmax, because that is the definition of Km. So I hope this makes sense, and thank you very much for watching.